start now lah. Mudah sebab the other one was ni, right? So I got some what do you call it, notes to be uploaded, and the boleh ni lah, can go through the notes, right? And presentation based on the PowerPoint. Boleh nampak hopefully you can see the, what do you call it, the PowerPoint though. Okay, so topic is sloshing analysis of membrane tank, okay, for the Malaysia LNG carrier, right? Next page. So we start with the introduction. I mean, first we analyze the effect of sloshing caused by partial filling. So normally LNG tak penuh lah, and it's not fully what do you call it, not fully loaded, so it can be partial, right? So and also sloshing phenomenon is deemed to be one of the most important design aspects when it comes to reliable design of cargo containment system, right, of the liquefied natural gas, LNG carriers. Research about sloshing that can cause serious incident in tank if sloshing happens at maximum impact, right? So Malaysia, as you know, is the biggest LNG exporter. Analysis on sloshing effect is important for better LNG transportation. Okay, so I think we kita record lah ni, ada orang minta record. Okay, it's already recorded. So normally we have what do you call it, the free surface effect. So we have tank filling levels, the natural pitching. Okay, so those yang biasa dengan kapal tahu lah. That means the pitching motion and rolling from port to starboard, pitching forward and aft, and liquid free surface effect can cause the liquid to move within the tank, right? So you can ask while presenting, you boleh tanya soalan, you can ask question. And we can study data taken from previous model experiment and compare data between other model experiments, right? And sloshing simulation using CFD. CFD means computer based, computational fluid dynamic software to identify the effect of filling level, right? So the scope of the research of the paper, research from previous model testing experiment, and then it's done using CFD software computer fluid dynamic simulation. And model testing cannot be done due to lack of facility. So we only do CFD. Model testing not done due to high cost and lack of time. Model testing will be done maybe in the near future, right? So LNG, okay. Normally LNG is slightly different from LPG. LNG is for commercial or industrial. So predominant by methane, right? CH4, right? The chemical composition, and cryogenic temperature minus 162 degrees centigrade. And in its liquid form, is 100 or 1600 of original volume, right? Compared to the gas form. Easy transport in liquid, odorless or colorless, non-toxic and non-corrosive. Okay. So normally the liquid content is slightly violent, right? In tanks subject to external force, ship motion. To mention about highly stochastic Means random probability.
Abang.
Okay, Assalamualaikum Tuan Haji.
Okay.
Baru selesai Tuan Haji, kita menyusrah. Minta maaf Tuan Haji.
Okay, no problem.
Okay, now you are prepared. So, saya nak letak dulu poster dalam tu ya. Kejap ya, share dulu.
Okay.
Sebelum saya buat introduction ya. So, 1 minute Tuan Haji.
Okay. Remove.
Kalau boleh Tuan Haji unset dulu Tuan Haji punya poster tu.
Jangan buat.
Nanti saya share kita punya dialog punya masa dulu ya.
Macam dia keluarkan.
Tusuk tu kita punya participant lah ya.
Okay. So how to remove this one? Okay, content.
No, just unset tu, dekat yang sharing tu just klik kat situ.
Share tu tak keluar.
Tak. Kalau Tuan Haji kat atas tu kan ada tanda yang first participant bla kan. Ada lagi kotak yang ada arrow ke atas. Kotak yang ada arrow ke atas.
Ya.
Nampak ya?
Dia turun bawah dah.
Nombor tak apa. Tapi dah klik itulah ya.
Dah.
Saya share Tuan Haji poster macam mana.
Okay.
Okey, Tuan Haji ada nampak tak poster yang saya share?
Ada.
Ada ya. So, okay, let me start with the introduction before Tuan Haji mulakanlah ya.
Okay.
Assalamualaikum warahmatullahi wabarakatuh and very good afternoon ladies and gentlemen. First of all, very sorry, my 1,000 apologies because we start a bit late today because we had another program before this. That is our weekly usrah. And for today's topic of discussion will be on sloshing analysis of membrane tanks for Malaysia LNG carrier. And we are very honored to have Tuan Haji Mazlan bin Muslim to present his topic today. And Tuan Haji Mazlan is our principal specialist at UniKL MIMET. And he's a person who has been involved so much about this offshore engineering and also naval architecture as well as marine engineering. So his topic today is very, very special, and we would like to share from what Tuan Haji Mazlan will present to us today. So inshallah. With that, Tuan Haji, I hand over to you to begin your presentation. Thank you very much, Tuan Haji.
Okay, thank you. So, all right.
So I've already unset the poster. So now Tuan Haji can put on your poster. All right.
Yeah. So replay. So we start from the beginning.
Yes.
From the beginning.
Right.
Okay. Yeah lah. We start.
So you are in control of your slide, Tuan Haji, yeah?
Okay. No problem.
All right. Please continue.
Yeah. Thank you. So thank you, Professor Salim, for the nice introduction for this one. So this one actually based partly of my experience in the MIC. I've been on the LNG carrier, but only short while I actually more on tanker, right? So here just sharing on the LNG. So we are more towards the sloshing, right? I think sloshing phenomenon is quite can imagine the condition in the tank, but actually more towards membrane, right? And in fact, previously we discussed before you introduce this membrane type is not the same as the what you call moss tank, the rounded one, right? The one is a moss tank, it's a membrane type. Okay, I think we'll show you the in fact the what do you call it? The photo of the LNG slightly after this. And as you know, sloshing phenomenon is one of the most important design aspects, right, for the cargo containment system of the LNG carrier. So there are some serious incidents in the tank if sloshing happen at maximum impact, right? So as you know, Malaysia is one of the biggest LNG exporter, right? And analysis of the sloshing effect is important for better LNG transportation. Okay, you can comment while I'm presenting, no problem. So free surface effect, tank filling level, natural pitching, and rolling movement of the ship at sea, and liquid free surface effect cause the liquid to move. So this is actually the how you have the sloshing for the tank. This one is one example of the membrane type. Actually, membrane type, you can see the structure on top is straight, right? Not like the moss type, which is rounded. So objective of the paper of this one topic: study data taken from previous model experiment and compare the data between other model experiments, and conduct sloshing simulation using CFD or computational fluid dynamics, right? Software to identify effect of filling level. So actually, filling level have effect on the sloshing or on the what do you call severe pressure on the tanks. So the scope of the paper of the presentation: research from previous model testing experiment and simulation in the CFD software. So for this time, we haven't done the model testing because of the lack of facilities and cost. Maybe in the future, right, we'll do it. And a little bit introduction of LNG. LNG. So the predominantly more towards methane, right, CH4, and the cryogenic temperature minus 162 degrees centigrade. So very cold, very cool temperature. And from the gas to the what you call liquid form is 1/600 of the original volume, and easily transport in liquid form, right? Odorless, colorless, and non-toxic and non-corrosive. So that's the LNG introduction. So what about sloshing, right? Actually, it's violent behavior liquid. So you can imagine, you can do your own experiment for some liquid in the what you call container. And of course, the sea, you have the external force or the ship motion. So the sloshing, you name it as highly stochastic or random probability, right, phenomenon. So these are some examples of the previous vessel. So the early LNG vessel, tanker, Polar Alaska in 1969. So hull capacity, that means up to 20%, and case during first ballast voyage, the phenomenon of resonance. So ship movement and the liquid cargo movement are in resonance, right? Cause wave to break inside the first tank towards the bow. So what improvement they've done, the chamfer of the tank, right, 45 degrees. And no flame will happen if tank is no oxygen evidence on electric cable torn inside the tank. So this one talking about the cable. The next example, Larbi Ben Mehdi incident at El Paso Shipping Company. So this one, Algeria, East Coast port of US, wavelength close to total length. So also some sort of resonance. Sloshing happened in the tank and damage about 45 boxes in all tanks, right? So on the old designer. And very detailed comparison of the GT Mark III and the GTT, what do you call it, number 96. So you can see the main comparison: corrugated membrane made of thin, low carbon stainless steel, and the other one, membrane made of thin metallic sheet of high nickel alloy, INVAR. Okay, so the detail you can read later because this one is recorded, right? So you can read the details of the membrane. So in fact, one of the participants, two of the participants are actually building this one, right? Building the containment system. So this is more detail. The Mark III, they have the primary barrier, secondary barrier, and the plywood. So RPUF foam actually is the, what do you call it? Reinforced polyurethane foam. Okay. So the one at the bottom is number 96, also from GGT. So we have the primary box and the secondary box at the bottom, right? So so how to do the test procedure, right? Firstly, you have to do a seakeeping analysis, right? In this particular sloshing study with objective to determine ship motion. So as you know, the ship motion depends on the wave condition and use as sloshing excitation for CFD calculation and sloshing model test. Okay. So this is a typical example. Actually, this one is more like Moss type, but just to show you the dimension of the typical LNG ship. So the length can be up to 290 meters, right? And cargo capacity about 150,000 meter cube. And the speed, okay, can go up to 20 knots, depend on the designer, okay? So, and inside the tank, the pump tower, this is the arrangement of the pump tower of the LNG tank, right? It also has some effect on the, what you call, the drag on the tower, okay, when sloshing happening. So it can also damage, right, the pump tower if the sloshing is very severe. So you can see now the why sloshing is important in LNG. Okay, so the membrane tank, right? First, we do a CFD numerical sloshing simulation to evaluate overall fluid kinematic and provide independent verification of sloshing effect on cargo tank wall, and evaluate the preventive design load of ship inner hull structure. So they one on the membrane, and they provide the fluid velocity and acceleration at pump mast location. So I think I shown the pump tower, right? It's a similar pump mast location for strength assessment. Okay. So model test standard, part of the comprehensive sloshing assessment. Test rig and motion generation be driven by 6-degree freedom motion generator to describe realistic ship motion. So for the model, you can have a geometrically similar to study tank with scale not less than 1:50. And sensor arrangement examined in predefined zone located at different hot spot inside the tank. Right. So the sensor being arranged, I think the arrangement will show next in the next slide. Transfer bulkhead above the lower chamfer height. Investigate consequence of longitudinal sloshing flow. And the sidewall above the lower chamfer height, investigate consequence of transverse sloshing flow. And corner between upper chamfer and the ceiling, investigate consequence of standing and breaking wave in interaction with tank top, right? So those in the shipping business know this all this terminology. So here the sensors. So maybe not so clear, but if you run the what do you call the record, you can see that. More at the joints, right, at the side here, and also at the end and the side of the tank, right. Data processing of impact pressure result can include noise, hydraulic pressure, low wave frequency fluid oscillation, and high frequency sloshing impact pressure. So high pass filter of 4 Hz used in order to eliminate hydraulic pressure and low frequency fluid oscillation. Okay. So actually, we work with MIC, of course. I was with MIC previously. Method of sloshing guidance, update the basic operation of simulation using Autodesk. This one a bit dated. I think maybe now we have some new software. So from MIC got the data, and for previous experiment of sloshing model test, right? So the flow chart. Actually, flow chart you have a cycle, what do you call it? Something like not exactly straight line, right? But this one is just an example, right? You see the from the data, and then we have the collect the information on the method for that. and study on previous what we call experiment and collect from data from LNG company. In this case, MIC, and then simulate sloshing using software and compare data. So this one, the what do you call the flow of the research, right? So basically, we can conclude from the above. Purpose of research to study about sloshing in LNG membrane tank. We can cause untoward incident to tank structure and boundaries. So from improvement of the tank design. So from the sloshing, you can do you can improve the design of the tank, and tank filling level can be determined. So I think later we can see the percentage of tank filling level cannot be certain percentage. I think we will mention upward. How determine how the result and conclusion from the study can be used for continued development of requirement. So I give example as ship classification Malaysia because we want to promote also Malaysian class. Expand study to cover tank parts, right? That likely to experience sloshing. Impact loads for lower filling levels in their quite different characteristics. Okay. And okay, this one I mentioned earlier on. So to avoid for the impact load, not less than 20%, okay, of tank width. It has also been found that the spatial and temporal pattern of impact pressure at low filling level is quite different from high filling case. The wider effective area of the impact pressure at low filling level indicate conservation of the impact pressure should be made more careful for the strength of the insulation system and bulkheads, right? So these are some reference of the paper for the presentation. Actually, some of them you can get, and also from the class, right? ABS. I think maybe they now they have a new one. This one was based on the previous one. 2014 strength assessment of membrane type LNG containment system under sloshing loads. So come under ABS guidance notes, right? So thank you very much. Okay. So now we can open for question and answer. So gentlemen, ladies and gentlemen, any question?
Right, ladies and gentlemen, it's a question and answer session.
Yeah. Anybody want to ask? But you can share because earlier on before our session, we have discussion with Cik Muhammad Liza and what do you call it? Siwa, Siwa. And also our what do you call it? Cik Azwan. So they have some experience on the what do you call it? Containment system. So maybe you want to comment, or any other people want to comment? So okay. So I think they focus on this one. Sorry. Here this one. Maybe this one is slightly dated. Slightly what do you call been established. Maybe now we have a new something new. So do you want to comment on this one? Is Lisa or Shiva or Azwan?
Ya, Assalamualaikum.
Alhamdulillah.
So apa khabar semua?
Alhamdulillah.
So saya kenal few people lah. So saya actually ex-MIMET DSD grad 2015. So saya dengan satu company yang kita design LNG containment. So saya responsible more on the design part dan benda yang berkait dengan architecture. Most of the CAD kerja saya buat. So tapi one of the things yang kita selalu study is the sloshing. Sebab for example in the membrane tank, kebolehupayaan kapal tu untuk membawa cargo sebanyak mungkin bergantung kepada dimension kapal tu kan. Jadi dimension kapal tu bergantung kepada size tank tu, macam mana dia boleh tahan daya dan load stress apa semua, bergantung kepada size tangki tu. Sebab kalau tangki tu terlalu besar, sloshing load tu terlalu besar, dia punya beam ada limitation. Jadi bila beam ada limitation, dia punya length pun akan limitation. Jadi that's why kita tengok benda tu. So bagi kita ni satu topik yang menarik lah. And then dia satu untuk for class approval yang dengan code untuk comply dengan code dengan kelas. Ni one of the things yang memang kita banyak study lah.
So any comment on the paper itself? Ada comment apa? Dia memang establish kan. This one is what you call the GTT, yeah. This GTT punya.
Is integrated tank lah. So,
integrated. So the one you build sama ke lain? Is it the same? Or
independent. So
independent lain lah.
Independent tank. So jadi hal dengan tank boleh buat asing lah. So,
this one is sekali This one integrated. Ya.
Ini integrated, hal dengan tank kena buat sekali kan. So kita macam pos lah.
Hi everyone. This is Shiva.
Okay. Hi.
This is Shiva. I'm Niza's colleague.
Okay.
So I just have one input here. The paper is overall, I find it interesting. As Niza said, this is a very important criteria, the sloshing, when you design the tank. One thing that I think I suggest to add on here is the reference to IGC code. IGC code is the most preferred standard for LNG carriers. So I think if we can make reference to IGC code, the paper can go like international level. The outreach will be more. That is one comment from my part. And one thing that interesting to me in this presentation, the sensor part.
Sure. Sensor.
The sensor part, just want to ask, what sensors are they? Is it the temperature sensors or pressure sensors?
Pressure. No, because I know temperature is more complicated because it's talking about thermodynamics, right? And all that. So that one we don't do lah. Actually more towards pressure because we want to know the effect on the what do you call it? Pressure level, different feeling. To what percentage of the filling of the tanks. So just now I mentioned about 20% that you have to avoid, right? And based on some simulation done. So maybe the next one will be temperature. Temperature.
Okay. So what is the maximum filling level it can have?
Maximum or minimum? 80%.
Maximum.
Anything above 80% should be okay.
80%. Okay. So it's 80%. So the danger zone is between 20 to 80%.
That's right. Yeah.
Okay. Thank you. That's all comment from me.
Okay. Right. Thank you. So maybe
I may ask something. I'm Salim. MIMET. I'm the organizer of the dialogues. All right. Looking at the figures that you put on the slides now, right? It seems to be. Oh no, leave it as it is. Yes, leave it as it is. The question is based on this figures here. I mean the diagram there.
Okay.
It seems that the barriers are of various layers. The barriers.
Sure.
Primary, secondary, and so on and so forth. In material made from plywood, foams. These are the standard material.
This one mentioned in the next slide, Prof. Sorry, in the previous slide. Here. So in fact, the one on top.
Primary, the metallic sheets.
Aluminum foil.
Secondary barrier made of thin metallic sheets. And then insulation, 2 layers of wooden boxes. Made of plywood.
That's right.
And what about the foam just now? Is it part of the insulation, the foams?
Foam is it's part of insulation. So you use reinforced,
reinforced, okay.
Yeah.
So this the primary and secondary seem to be metallic sheets. So it means that it is gas proof, LNG proof,
Yeah. So in fact, they're talking about membrane because the
membrane
empty barrier is the membrane. That means so the one on the right, in VAR, right? They want a special material. nickel alloy. So maybe our friend can comment on that.
Right. So normally this tank is very big tank for LNG carrier. Yeah?
Just now I
How
mentioned
do you address the effect of free surface? I think you mentioned in your, but it was not very clear.
Yeah.
Because the filling, as you mentioned, is about 80% in it. So
maximum.
That's, of course, because to allow the expansion of the gas.
Yeah.
So with that level of fillings, how do you handle the free surface effects? Because the gas is in a liquids. So I believe what sort of way do you reduce the effect of this free surface? Yeah, because the tank normally very large tank in it. So.
Sure.
Right.
So normally we have to do some talking about stability calculation. For normal shape, the IMO criteria is 0.15 minimum, right? The GM value. But here LNG, I think it should be higher. It should be so that because the effect of free surface will make the GM lower, right? So it has to be calculated, properly calculated in the stability.
Meaning that the stability is being handled in the design. Due to this free surface.
Yeah, our main concern here, Prof, is more on the pressure because the what do you call it? Impact pressure on the membrane, because a lot of failure happen. I think mentioned by Indo, Humaniza and Shiva, right? They have experienced one. So
the pressure due to sloshing,
that's right. So sloshing, and also ship motion combined, and then we have resonance. So there's a worst case. That's why sloshing for especially LNG is considered important for the for people in this field in the LNG business. So yeah, just giving some thought. But it's good that they say it's interesting on this topic since they are doing it. So maybe this Niza and so Shiva, if you don't mind, later you can send your email to us, right? I think you got the email, kan? And you can communicate or can have more.
So, Mr. Niza and Mr. Siwa, which company are you from? Petronas?
No. We are from Altair. We are a product engineering company.
Product
engineering company.
Yeah.
So Altair is so saya dengan Shiva daripada Altair. So dia US based company tapi dia ada office dekat.
Yeah.
So, dia punya main business is engineering software consultancy, tapi kita ada project team yang develop pattern LNG tank. So kita compete directly dengan membrane dengan MOS. So dia punya team R&D ada sebahagian yang duduk dekat KL. So tapi kita ada kerjasama juga lah sikit-sikit dengan Petronas, partner-partner lain.
The company that you are working with is an international company, is it?
Betul.
International, yeah. Right. So you are basically designers of this sloshing tank. LNG tanks.
Tank, membrane tank.
Kita punya type lain sikit lah, jenis kita lain sikit lah.
Because this one is patented. GGT kan? GGT is a brand name. It's a brand.
So your design has been applied in any one of the ships, probably Malaysian registered ships.
Hopefully soon enough.
Hopefully lah.
Soon enough. Yeah.
Okay, so your client will be MIC. Sorry, it will be MIC lah. Your client.
MIC tu one of kita punya prospect lah. Tapi for now MIC kita tak ada yang soon punya benda lah. Bukan MIC lah. So ada private player lah.
Okay.
Time insyaAllah benda tu akan.
Alright, good.
Okay, Prof, itu je punya tu. Unless ada soalan lagi apa?
Is there any more question from other participant probably?
Azwan, nak tanya apa-apa? Azwan? Tadi macam ada minat. Azwan still there? Tak ada? Azwan lah. Tanya apa boleh?
Azwan also is our guest. There are also, our own staff and also student, I think.
Ya, betul.
Staff 1. So, ladies and gentlemen, is there any more questions?
Tak apa, tanya je, tanya.
Tanya je.
No problem. Dr.
So,
Azli,
our expert on this LNG tank design in our campus is Tuan Haji Mazlan. He has been involved in
MIC pernah turun
particular type of vessel. I think when he was in Korea last time before.
Japan.
Yeah, in Japan before joining UniKL MIMET. So he has a very vast experience as far as the construction of this particular vessel is concerned. So anyway, thank you very much for sharing this, Tuan Haji Mazlan, and also our guest just now, Mr. Muhammad Niza, and also Mr. Siwaraja. Yeah. So,
thank you, Prof.
So if there is no more questions, should we adjourn now, Tuan Haji?
Sure.
All right. So it has been very interesting presentation from Tuan Haji Mazlan, our principal specialist at UniKL MIMET, and he has many more topics, I believe, to present in the future. It can be related to LNG tanks and also on other aspect on naval architecture, also marine engineering as well. Hopefully, he will be keep sharing with us in the future. So our dialogue session is every Friday, generally from 4 to 5 o'clock. Now I think it's about the right time. Time is about 5:03 now. So if there is no more question or sharing from other participants, we can now adjourn our dialogue session. Hopefully we can meet again in another session.
Record dia boleh access ke, Prof? Record. Ada orang nak they want the copy of the record.
Once we have the recorded session, then we can share.
Ada di sana recorded?
We can share. All right.
Okay. All right.
That's all for today, ladies and gentlemen, and thank you very much for your time and for your patience in listening to the presentation. Very interesting presentation from Haji Mazlan. And hopefully we will have other topics in future, right? Every week. So please watch out our programs on Friday between 4 to 5 o'clock. It's very short, but short and concise, very compact. All right.
Okay.
So with that, ladies and gentlemen, thank you very much, and hopefully we can meet again in other session in the future. Thank you very much. Bye bye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you very much, everyone.
Okay. Thank you.
Thank you and bye.